Hello everyone, welcome to BT 12503 Business Finance. This is topic 6, the time value of money. In this topic, we're going to understand the concept of compounding interest and calculate the future value of cash flows. Secondly, we are going to cover about discounting methods and calculate the present value of cash flows. And the last part of the topic is that we're going to learn how to calculate the present and future values of ordinary annuity and annuity due. Now, first of all, let us understand the basic concept about time value of money itself. What is actually the time value of money? Well, basically, it is a concept that a sum of money is worth more now or today than the same sum that will be received at a future date, which means that, in other words, the money that we have today, the value of the money that we have today is worth more than the same value of money that we will receive sometime in the future. For example, if today the value of 100 ringgit is worth more than the value of the same amount that we are going to receive in the next 2 years, or 2026, 100. Why? Because one reason is because of inflation factor, right? We all know that the rise in inflation will slowly, okay, have domino effect in everything, and eventually it will slowly reduce our purchasing power as a consumer. For example, with 100 ringgit today, we might be able to buy 15 items, right? If you go to any stores for grocery shopping, with 100 ringgit, maybe we could afford to buy like 15 items. However, in 2026, the value of 100 ringgit, okay, maybe we could only afford to buy between 6 to 7 items. Why is this happening? Because over time, okay, the value of money will slowly reduce due to many factors. One of it is because of inflation. Okay, because of inflation, it will increase the cost of products and services, right? So slowly, the price of goods and services will increase. When that happens, it will slowly reduce our purchasing power as a consumer, right? So everything slowly will become more and more expensive. So that is why 100 ringgit today is still valuable. If you compare, okay, with 100 ringgit that you are going to receive, okay, in the next 2 or 3 years, because of the inflation factor. Imagine, okay, 1 ringgit today. What can you do with 1 ringgit today? Nothing much, isn't it? Even if you want to go to the toilet at the shopping mall, you'll have to pay 50 cents to go to the toilet. Nothing much you can do with 1 ringgit today. But back in the 60s or 70s, with 1 ringgit, you can do a lot of things. You can enjoy a very nice cup of coffee. You can enjoy a very nice nasi lemak and so on with only 1 ringgit. But today, with 1 ringgit, there's nothing much you can do about it. Somehow it become invaluable, less valuable. Okay, so that's the effect of inflation. That is one concept, time value of money. Second reason why the money, the value of the money is worth more today than sometime in the future, because of the investment factor. For example, if you have 100 ringgit today and you invest it in any accounts or any financial instruments that can give you some percentage rate of return, this money will grow more than 100. Let's say if you put 100 today in a fixed deposit or in a, you know, whatever instruments that is available out there, years later, maybe somewhere in 2026, the value of your investment might increase to 130, for example. So you would enjoy a return of 30 ringgit. So it's because of investment factor. So investor prefer to receive money today than the same amount of money in the future, because once the money is invested, the value of the money will grow over time. For example, if you deposit your money into a savings account, you get return from the savings or investment. Over time, the interest will be added to the principal, earning more interest. That's the power of compounding interest. So when you leave your 100 in the savings deposit account and you leave, okay, the money to grow, let's say the interest rate is 5%, okay, you leave the money to grow and interest is compounded. By 2026, perhaps the value of money will increase to $130. So you would enjoy a 30 ringgit of return. That is time value of money. So two reasons. Why? Because why does the value of money is worth today than the same amount of money in the future? Because of two factors. Number one, because of inflation factors. Because of inflation, the price of goods and services will tend to rise, which eventually reduce our purchasing power. So because of that, the value of the same amount, which is 100, sometime in the future, might worth less than what it is valued today. Secondly, because of the investment factor, all right, whereby when you invest your money and you leave it there, then the money will grow over time and you would enjoy your profit. So that is the concept of time value of money. All right, so the time value of money calculations basically involve calculating the present value and also a future value of money. Let's go with the first one, compounding and future value. So in calculating future value, the idea is that we want to see what would be the future value of the money that we receive today. For example, if we have $1,000 and you leave it in any accounts that give you a return, somewhere in the future, what value of this 1,000 be in the future? This is what we want to find out, right? So to calculate future value, basically it is equivalent to present value bracket 1 plus annual interest rate, or I, over number of years, or N. For example, suppose that you deposited $500 in your savings account that earns 5% of annual interest rate. How much will you have in your account after 2 years and after 5 years? So to better understand this question, it is best to start drawing with a timeline here. So today you deposit $500. Okay, let's say you get $500 from your family members, or Christmas present, or ang pao, or bonus you get from your company. So you don't want to spend this money, but you want to invest it. Okay, so assuming you invest your $500 and you put in any accounts that could give you a return around 5%. The question is, how much will you have in your account after 2 years? So in 2 years' time, how much this 500 will be worth if you put in an account that give you 5%? So if we apply the formula of calculating future value, we call this future value of a single sum. Why single sum? Because you have $500 and you just want to leave it there in the account and let the money grow. Okay, so what this value of 500 will be in the next 2 years. So applying this formula, you have the present value, which is the value of 500 today, 500. 1 plus I, or the interest rate, is 5%. So 1 plus 5%, that will be 1.05. Power of n is time or years, which is 2, right? So if we calculate, you get the future value of 551.25 cents. In other words, if you leave your 500 today in the accounts that give you 5% of return, in the next 2 years, the money will grow up to 551.25. What the value will be after 5 years then? So the same thing applies here, right? In 5 years' time, if you leave your money today in $500 with a return of 5%, okay, in 5 years' time, you would get a return around $638.14. Okay, so in other words, in the next 5 years' time, the longer the period, the higher the value of your savings or investment will be. This is what we call the effect of compound interest, whereby you leave your money in the account, okay, for 5 years, okay, and you let the money and the return grow in value, okay, compound interest. If you refer to the table here, okay, this is what we meant by the effect of compound interest, whereby initially you have your savings of $500, and in the first year you receive a return of $25, okay, because of the 5% of return. The ending value is 525. Moving on to the second year, you will have a new beginning value, 525, and you earn another interest of 5%, which is 26.25 cents. And this 26.25 cents is further added in the beginning value of 525. Therefore, at the end of year 2, your value of your investment increases to 551. You see, this is the effect of compound interest. So if you leave the money there, 500, without withdrawing it, okay, just leave it there, then you would see the effect of compound interest like this. Okay, this is where the money grows over time. This is where the money grows over time, and eventually, at the end of year 5, the money further grows up to $638.14. The effect of compound interest. The problems with our people nowadays when they save or invest their money, okay, they save today and a month later they withdraw, save and withdraw, save and withdraw, save and withdraw. By doing that, you won't see the compounding effect, and there's no way you can get a good return from your savings and investment. However, if you dump the money there and just leave it there, assume that nothing is happening, and you don't withdraw it, then you would see the effect of compound interest, whereby you will see your money will grow over time, right? So if you want to enjoy the effect of compound interest, and if you want to enjoy the profits from doing savings and investment, then you should not withdraw frequently when you save or invest your money in any instruments, right? This is what we call the effect of compound interest. You let your money grow over time. Now, speaking of the compounding effect, eventually, compounding effects can either be annually or could either be semi-annually, quarterly basis, or monthly basis, or weekly basis, or even daily basis, right? So if you compare this table, if you want to see a higher value of the compound effect, right? If you see here, the more frequent the money is being compounded, the higher value of the money will be somewhere in the future. For instance, if the money is compounded annually, like this here, right? And if the interest rate is 15%, if the money is compounded annually, then eventually the value will be 115. But if the investment or the money is being compounded monthly, setiap bulan, compounded monthly, eventually with the 15% of return, you would get much higher return. That's the difference in terms of the effect of compounding methods if based on the frequency of it. Okay? So the more frequency of the compounding effects, for example, if it is compounded monthly, okay, compounded monthly means every month the interest is being compounded or accumulated. Okay, this is, let's say, if this is monthly, this is yearly. Yearly means compounded once in a year. Okay, the more frequent the money is being compounded, the more return you will get. A higher value the money will grow. If you deposit 50,000 in an account that pays an interest of 10% annually, however, the interest is being compounded monthly, what will be your account balance be in 10 years' time? So if we draw a timeline here, in 10 years, what's going to be the future value if today you deposit 50,000 and the interest of 10% is compounded monthly? Meaning to say every month you will get a return. Not 10%, but because this 10% is annual return, but it is being compounded monthly. Okay? So monthly compounded means every month you will get a percentage rate of return from this investment. So what would be the future value of this 50,000 today if the return is 10% compounded monthly? So applying the same formula, we know the present value is 50,000. 1 plus I. The I is 10%. Okay. However, this 10% is an annual return. If it is compounded monthly, meaning to say 1 year we have 12 months, right? So if it is compounded monthly, therefore the 10% of interest will have to divide with 12, which means 12 months. Okay, we have to divide with 12, while the N here, okay, is 10 years. Since it is compounded monthly, so we have to times with 12. Okay, that's how you calculate when the interest is being compounded monthly. Okay, so by doing this, okay, and if you calculate further, you would get a return around 135,352.07. Right. So if the investment is compounded monthly, we would get a return around 135,352.07. This is if the investment is compounded on monthly basis. Now, what if this investment, this money is being compounded annually? What would be the value? So if it is compounded annually or annual basis, the same calculation formula, 50,000, 1 plus I, or 1 plus 10%, we get 1.10. We don't have to divide with anything because it is compounded annually. So terus compound setahun. So remains the same. Okay? And the N is 10 years because it is compounded annually. So if you calculate this, you would get 129,687.12. So if you invest 50,000 in an account that give you a return of 10% compounded annually, the money will grow up to 129,687.12. Now you see the difference here. If your investment is being compounded annually, this will be your return. However, if your investment is compounded monthly, you get more return, right? So that's the difference on the effects of compounding methods if it is being compounded annually and monthly. So the more frequent compounding methods there, the more returns that you will get. Now, apart from monthly basis, sometimes, okay, the compounding effect also can either be on semi-annually basis. Semi-annually means in 1 year, the investment is being compounded twice. Okay, in 1 year, your investment is being compounded twice. So how do you calculate? If the interest is 10%, then if it is compounded semi-annually, then interest you divide with 2 because semi-annually. 1 year, payment twice. While the N, for example, if it is 10 years, you times with 2. What if it is compounded quarterly? Quarterly means in 1 year, okay, divided into 4 quarters. First quarter, second quarter, third quarter, fourth quarter. Okay, the first quarter may be from January to March. Second quarter, April to June, and so on. So you receive the interest compounded 4 times in a year. So if the interest is 10%, therefore you divide with 4 because quarterly basis. And if the N is 10 years, then you times with 4. So same thing applies if it is monthly basis, weekly basis, or daily basis. So that is on the effect of compounding interest according to the frequency of the compounding methods. Now, the next part in time value of money is calculating the present value, or we call it a discounting method. The key question in present value is that it answers the question of what the value today of cash flow to be received in the future. All right. So the answer to these questions requires computing the present value, or in other words, calculating the value today of a future cash flow that we are going to receive. And this process is called discounting methods. For example, in 3 years' time, you are going to receive $1,000. What will be the value of this $1,000 today? That is what we want to find out. That's the present value. And this process, okay, is what we call a discounting method. Discounting method. Discount means the value of the future cash flow, when we discount it backwards, okay, then usually the value will be lesser than 1,000. The same thing, if you go to a shopping mall, okay, and you see a nice cloth, original price is $500. And if it has a discount price of 50%, then the value of the cloth will be 250, right? So the same thing applies here. Okay, when the original value is 500 and it is being discounted at 50% of sale, in sale price, then the value of the cloth will be 250. This is what we call a discounting method. Okay, and this is why we calculate the present value. How do we calculate present value? Based on this formula. Present value equivalence to the future value, bracket, 1 over 1 plus I, power of n, and close bracket. This is the formula to calculate present value of a single sum. For example, what is the present value of 100,000 to be received at the end of 25 years, given a 5% discount rate? So to better understand this question, let us draw a timeline. In 25 years of time, you are going to receive $100,000. What is the value of this $100 today? This is what we want to find out. Okay, what is the value of this 100,000 today if the discount rate is 5%? So applying the same formula, present value equivalence to future value, 1 over 1 plus I n. Now we know the future value is 100,000. One plus I is 1.05. N is 25 years. So if you calculate this, you will get 29,530.27, which means that the 100,000 that you are going to receive in the next 25 years, the value of it today is only worth around 29,530.27. Right? That's the value today. And that's how you calculate a present value of a single sum. Now, in time value of money, there are times where we want to calculate the number of periods and the rate of interest. Sometimes we don't know or difficult to estimate. What would be the number of periods and what rate of interest we should invest in order to achieve some amount of money somewhere in the future. So how do we solve number of periods and rate of interest? Let's go one by one. Now, to solve for the number of periods, it means that how long will it take to accumulate a specific amount in the future? For example, how many years will it take for $10,000 to grow to $200,000 given a 15% compound growth interest? If you draw a timeline here, you have a money today worth $10,000. Let's say this is your bonus that you receive from your company, okay, or from your family members, and you want this $10,000 to grow to $200,000, okay, and you invest this $10,000 in an account or any investment instruments that could give you a return around 15%. The question is, how long will it take for this 10,000 to grow to $200,000? Meaning to say you want to find the N, the number of years. Okay, you put this 10,000 in a 15% of return account, and you want this money to grow to $200,000. The question is, how long will it take? So how do we calculate this? Now, we can calculate this either using the future value formula or the present value formula. So you have two options. Number one, either use the future value formula, future value interest factor formula, or you can use the present value interest factor formula. That's what we have covered just now. Okay, so if you use the future value formula, then you will have to use the future value table. So in order to find the number of years, we are going to use the time value of money table, okay, which is available on ITEL. So let's use the future value formula. If we use the future value formula, okay, you know this is the formula, right? What is the present value here? The present value is 10,000. And what is the future value? 200,000. Okay. 1 plus I. What is the interest? 15%. So we know the interest is 15%. And we want to find the N. So how do we deal with this? The first step is that we divide 200,000 with 10,000. Okay, divide 200,000 with 10,000. You would get 20. Okay, so we got this 20, and we know the interest is 15%, right? The next step is to refer to the time value of money table. So again, if we use the future value formula, we have to refer to the future value table. Future value table. Okay? If you use future value formula, you have to use future value table. What is the table? This one. Okay, it's written here. A future value interest factor compounded. This is a table. Okay, future value compounded table. So we know the interest is 15%, right? From our calculation just now. And we have the figure of 20 from here. Okay, so what we have to do, we refer here. This is the interest, okay? This side here tells you in percentage, okay, which is the interest. This side here is the period side, the period side, or the number of years or months. So we know the interest is 15%, so we refer here 15%. Okay, and we scroll down further until we found 20. Look for 20 somewhere here. Scroll down and look for the figure of 20. So it falls somewhere here, isn't it? It falls somewhere here between 18.821 and 21.644. So 20 is somewhere around here. Correct? So what do we do next? We move on to the left and look at which period does this number falls. So if you look at here, it falls between the period of 21 and 22. So which means your N is between 21 to 22 years. That is the answer. All right. So back to the question. How many years will it take for your 10,000 to grow to 200,000? The answer we got just now, it will take around 21 to 22 years for your 10,000 to grow up to 200,000. How do we do it? From referring to the table. 15% of interest rate, you go down and look for the figure of 20, which falls somewhere here, and you refer to the period, it falls between 21 to 22 period. So that is the answer. Now the same thing, if you use present value formula, okay, if you don't want to use future value, you can also use present value formula. If you use present value formula, that means we have to refer to the present value table. Okay, so we know the present value is 10,000 and the future value is 200,000, right? And we know the interest rate is 15%. So same procedure, you divide 10,000 with 200,000, you will get 0.05. Sorry, 0.05. And we have the interest of 15%, right? So again, if you use present value formula, you have to use present value table, which is this one. Okay, it's written there, present value interest factor discounted. This is the present value table. So we have the interest of 15%, and we have the figure we calculated just now, 0.05. So simply go to 15% of return. You scroll down further until you find figure of 0.05. So here we have 0.09, 0.08, 0.07, 0.06. There you have 0.053 and 0.046. So 0.05 is somewhere in the middle here, between 0.046 and 0.053. Okay? Somewhere here. So you go to the left and you find that it falls between the period of 21 and 22. So you get the same answer. The N is 21 to 22 years. The same answer. If you use future value or present value, you will get the same answer, whereby it will take around 21 to 22 years for your 10,000 to grow to $200,000. Now, another thing that we want to solve is the rate of interest. Okay, solving for the rate of interest is when we want to calculate at what rate of interest will allow your investment to grow to a desired future value. So again, we can determine the rate of interest using the financial table. For example, at what rate will 50,000 have to grow to reach 1 million in 30 years' time? So if you draw a timeline, in 30 years' time, okay, today you have 50,000 and you want your investment to grow to 1 million. Okay, you have a 50,000 bonus and you want to have 1 million in 30 years' time. The question is, at what instruments or what rate of investment that you should have in order for this 50,000 to grow to 1 million in 30 years' time. So again, the same thing applies. You can either use future value or present value formula. If you use future value formula, you have to refer to the future value table. Now we know the future value is 1 million and the present value is 50,000. We don't know the I, but we know the number of years. So the N is 30. Okay? Or N or also period. So simply divide 1 million with 50,000. You would get 20. And you have N 30. So if you refer to the future value table formula, this one, future value formula table, we have the period or the N 30 and we calculated the figure just now 20. So instead of, we don't know the percentage yet. So we have the N, which is 30. So we go to the period here and we look at 30. Okay, N 30. And we scroll further until we found the value of 20. So 20 falls between 17.449 and 22.892, right? So 20 falls somewhere here. Okay. So you go up and you found the answer here, between 10 to 11%. Which means for your 50,000 to grow to 1 million in 30 years' time, you will have to put this investment in an account that can give you a return between 10 to 11%. Okay? You have to put your investment in any accounts or investment instruments that could give you an average return at least between 10 to 11% in order for this 50,000 to grow to 1 million in the next 30 years of time. That's how you calculate. If you use future value formula, and the same thing applies if you use present value formula, you have to refer to the present value table. So we know the present value is 50,000. Okay, future value is 1 million. So you divide 1 million with 50,000. Sorry, you divide 50,000 with 1 million. You get 0.05. And you know the N is 30. So you refer to present value table here, the present value table. Okay, we have the period of 30 and find the value of 0.05. Fall somewhere here between 0.044 and 0.057. So 0.05 falls somewhere here. You go up and see falls between 10 to 11%. So the same answer, okay, like if we use the future value formula, which means that you will have to earn an annual interest rate of between 10 to 11% for 30 years in order to increase the value of your investment from 50,000 to $1 million. Now, the next concept in time value of money is annuities. What is annuity? An annuity is a series of equal dollar payments that are made at the end of equidistant points in time, such as monthly, quarterly, or annually basis, over a finite period of time. If the payments are made at the end of each period, that means the annuity is referred to as ordinary annuity. Again, what is annuity? It is a series of equal dollar payment. Equal dollar payment. Okay, for example, you save $1,000 consistently every year. So let's say this is the number of years. Okay, first year, second year, third year, fourth, fifth, sixth, seventh year, 8 years. Every year you save 1,000 consistently. 1,000, 1,000, 1,000, 1,000, 1,000, 1,000. So this is what we meant by annuity. It is a series of equal dollar payments. Now, if you save $1,000 consistently at the end of every year, okay, at the end of every year means sometimes in November or December, for example. Or if you save the money at the end of every month, let's say end of January, maybe 29th of January or 28th of February, okay? So if the payments are made at the end of each period, either on month or year, then the annuity is called ordinary annuity. Ordinary annuity, yeah? So ordinary annuity is when the payments are being made at the end of each period. So that is annuity and the concept of ordinary annuities. Now, how do we calculate the future value if it is if the payments are being made on ordinary annuity basis? For example, how much money will you accumulate by the end of year 10 if you deposit 3,000 each year for the next 10 years in a savings account that earns 5% per year? The question here is, how much money will you accumulate by the end of year 10? How do you know if this question asks about ordinary annuity? It mentioned here, by the end of year 10, pada penghujung tahun yang ke-10. So you save consistently every end of the year, all right, 3,000, okay? Every end of the year, you save consistently 3,000. Okay, and the question asks you, how much money will you accumulate by the end of year 10? Okay, pada penghujung tahun yang ke-10, how much the money that you save every year will be accumulated? Okay, assuming that you invest your money in an account that gives you a 5% of return. So the question asking you about finding the future value of annuity. Okay, so to calculate the future value of an ordinary annuity, we will use this formula. Okay, this is the future value of an ordinary annuity formula, which is equivalent to PMT. PMT stands for the annuity payment that you deposit consistently at the end of every year, which is the 3,000. Bracket 1 plus I, which is the interest, over N, the number of periods, minus 1, you divide with I, which is an interest rate, and close bracket. So if we calculate, okay, the PMT is the 3,000 that you save consistently every year. 1 plus I, the interest rate is 5%, so 1.05. 1.05. N is 10 years, so N is 10 minus 1, divide with 0.05 is the interest rate. So what do you get? Let me just calculate this. Over 10 minus 1. You would get 37,733.67. Okay, 377.40. Okay, the same. Just a difference in decimal place there. But it should be okay. 377.40 or 377.33.67. So which means that if you save consistently 3,000 at the end of every year, by the end of year 10, the value of your savings will grow up to 37,733.67, or to be exact, $37,740. And that's how you calculate a future value of ordinary annuity. Now, you may also want to calculate how much you need to save each period, or in other words, you want to find out the PMT in order to accumulate a certain amount at the end of certain years. So, in this case, we have the future value, we have the interest rate, we have the number of period, but we want to know how much we should save every period of time. For example, if you can earn 12% on your investments and you would like to accumulate 100,000 for your newborn child's education at the end of 18 years, how much must you invest annually to reach your goal? So you just you are about to plan for your newborn child, okay? And when your child, or your, let's say your daughter, reach the age of 18 years old, you want to have at least $100,000 in her account, right? And you plan to save in financial instruments or investment instruments that can give you a return around 12%. The question is, how much, okay? How much should you save or deposit or invest every year? This is about solving the PMT, right? This question is quite practical if you want to do financial planning for your family. Okay, in this case, you just give a birth to a newborn baby, and you plan that when she reach 18 years old, you want to have at least 100,000 in her account. So this is one way how you can plan for your child's education. Okay, assuming that you put your investment that in a account that can give you 12% of return. Question is, you don't know how much exactly should you save every end of the year. So it's again solving for PMT. Okay, so we know the future value is 100,000. We don't know the PMT. Okay, the interest rate is 12%, so 1.12. N is 18 years minus 1 over 0.12. Okay, so if you calculate this, okay, you would get final answer of 1,793.67. 1773 or 1793, which means that in order to have 100,000 when your daughter reach 18 years old, and if you put the money in an account that gives you 12% of return, you need to at least invest or save around 1,793 consistently every year. 1793 every year. Okay, this is what you need to deposit or save or invest consistently every year. Okay, and eventually you will get 100,000 of savings by the time your daughter reach the age of 18 years. So the next part is solving for interest rate in ordinary annuity, which is quite similar with our previous discussion just now on how to find the interest rate if it involve ordinary annuity payment. All right. So in this case, we know the value of N, we know the value of PMT and future value, but we don't know the value of I. So how do we calculate? For example, in 20 years, you are hoping to have saved 100,000 towards your child's college education. If you are able to save 2,500 at the end of each year for the next 20 years, what rate of return must you earn on your investments in order to achieve your goal? So if you draw a timeline, okay, in 20 years, you hope to have saved $100,000 on your child's education. If you can save 2,500 at the end of each year, so every year you want to save 2,500 every year. At the end of each year, right? At what rate of return must you earn on your investment? So we want to find out the I here. So we have the data on the period. We know what is the future value. We know what is the present value. So how do we solve the interest rate calculation? We can use the future value formula of ordinary annuity. So the future value is 100,000. The PMT is 2,500. And we have the number of years, which is 20 years or 20. So simply divide 100,000 with 2,500. You'll get 40. Okay, you get 40. So we have 40 and we have N20. So if we use future value ordinary annuity formula, then we have to use the future value ordinary annuity table. Okay, or we call it FVIFA, future value interest factor annuity. Okay, I repeat, if you use future value ordinary annuity formula, you have to refer to the future value of ordinary annuity table, which is this one. It's written here. Future value interest factor of annuity compounded. See the term annuity there. So refer to this table. Okay. So again, we have N, which is 20, and the value of 40 we calculated just now. So if we look at the period of 20 here, and we scroll further until we found the value of 40, which falls between 36.7 and 40.995. So 40 is somewhere in the middle here. So you go further up and you see the percentage rate falls between 6 to 7%. Between 6 to 7%. So that is the answer. So which means if you want to have 100,000 in the next 20 years, where you can save at least 2,500 every year, you should invest in an account that can give you a return somewhere between 6 to 7% of return. Okay. Now the same thing applies if we want to solve for the number of period. Just now we talked about solving the I, the interest rate. Now we want to solve the N in an ordinary annuity. For example, you are planning to invest 6,000 at the end of each year in an account that pays 5%. How long will it take before the account is worth $50,000? So if you draw a timeline, okay, you plan to invest 6,000, 6,000, 6,000, 6,000 consistently at the end of every year in a savings account that pays a return around 5%. Okay, and at the end of the period, sometime in the future, you want your saving worth around 50,000, or in other words, you want to have a total savings around $50,000. Okay, the question is how long? How long will it take for your 6,000 of savings every year to grow up to $50,000? For how long will it take? Means this is about solving the number of periods, or N. Okay, so to solve the number of periods in an ordinary annuity, if we use the future value formula, okay, we know the future value just now at 50,000. Your PMT is 6,000. Okay, and the interest, or I, is 5%. So we divide 50,000 with 6,000, should get 8.333. Okay, 8.333. The interest is 5%. So if we use future value of ordinary annuity formula, then we have to refer to the future value of ordinary annuity table. Okay, the same table just now. Future value of ordinary annuity table. So you go to 5% of interest. You scroll down until you found a figure of 8.333. So it should fall somewhere here between 8.142 and 9.549. So 8.333 is somewhere in the middle here, right? So you go to the left and look at the period where it falls. So it falls between the period 7 to 8, which means that it will take between 7 to 8 years before the account is worth $50,000, right? So again, in other words, to have your money grow up to $50,000, if you save consistently every year 6,000 in an account that gives you 5%, okay, it will take about 7 to 8 years for the money to grow to $50,000. And that is how you solve the number of periods in an ordinary annuity. So just now we talked about calculating the future value of ordinary annuity. The next part is on calculating the present value of ordinary annuity. Okay. Now before that, what is present value of an ordinary annuity? It is, okay, a calculation that measures the value of today of a stream of cash flow occurring in the future. Basically, more or less is similar with the present value concept, but again, it involves an equal ordinary annuity payment. To calculate the present value of an ordinary annuity involve a different formula. Okay, present value equivalent to PMT bracket 1 minus 1 over 1 plus I n over I. So this is the formula to calculate the present value of an ordinary annuity. Now let's take a look at one example on calculating the present value of ordinary annuity. What is the present value of an annuity of 10,000 to be received at the end of each year for 10 years given the 10% discount rate? So again, you draw a timeline to better understand the question. It asks you what's the present value of annuity of 10,000 to be received at the end of each year for 10 years. So which means that at the end of every year, pada penghujung setiap tahun, at the end of every year, you are going to receive 10,000. You're going to receive 10,000 at the end of every year for 10 years. Okay. The question is, what is the present value of this 10,000 annuity? In other words, what is the present value of every stream of future cash flows of 10,000 that you are going to receive every year in the future? This is what we want to find out. Okay, what is the value of the 10K that you are going to receive every year? What is the present value today? Okay, if the discount rate is 10%. That is the question. So to calculate the present value of ordinary annuity, okay, we use the formula just now. 1 minus 1 over 1 plus I n divided by I. So we know the PMT is 10,000. 1 plus I, the interest rate is 10%, so should be 1.10. N is 10 years. Then divide with 10% or 0.10, close bracket. So if you calculate this correctly, give me a moment, let me calculate. 1.10 over 10. You should get 61,445.67. This one. Which means that the future value of annuity that you are going to receive every year, the value today is around 61,445.67. Okay, that is the present value of ordinary annuity. Now, the last part of the chapter is annuity due. What is annuity due? So annuity due is an annuity in which all the cash flow occurs at the beginning of each period. For example, rent payment on apartments are typically annuity due because the payment for the month rent occurs at the beginning of the month. Okay, so annuity due is a series of equal payment whereby the payments occurred at the beginning of each period. For example, if the beginning of the month, maybe the first week of January, for example, okay, beginning of every month, first week of January or second week of, or first week of February, first week of March, and so on. Or maybe beginning of the year, maybe for that particular year, the payment occurs on January or February instead of December or November. Okay, so that is what annuity due is. The equal series of payment occurs at the beginning of the period, either in month or year. So if occurs at the beginning of the month, maybe somewhere around first week of the month. Contohnya first week of January, first week of February, and so on. Okay, that's the difference between annuity due. Annuity due, again, annuity due, payments occurred at the beginning of period. Okay, while ordinary annuity just now, the payments occurred at the end of each period, isn't it? Okay, at the end of each period. For example, at the end of the year means the payment occurs somewhere in December. Kalau at the end of the month means the payment occurred maybe on the 28th of January or 28th of March at the end of the period. So that's the difference between ordinary annuity and annuity due. Now, in terms of calculation involving future values of annuity due, how do we calculate? Well, basically, it's quite the same with future value of ordinary annuity. So if you want to calculate the future value of annuity due, the formula of future value is the same. Future value of annuity is just that if it involves annuity due, you just add 1 plus I at the back. That's all. Okay, it's the additional of 1 plus I at the back. If the questions talks about annuity due, okay, payment occurs at the beginning of the period. So if you happen to see the questions mentioning that, okay, your payment occurs at the beginning of the year, and please calculate the future value. That means you have to use the future value annuity due formula, which is this one. Okay, more or less it's the same with future value ordinary annuity. The only difference is that in annuity due, if you want to calculate the future value, you just add 1 plus I at the back. Now, the same thing applies if you want to calculate present value of annuity due. The formula of present value of annuity is still the same. It's just that you just add 1 plus I at the back. That is all. Okay. So very important for you to read the question carefully and determine whether that question talks about ordinary annuity or annuity due. If the question mentioned about payments are being made at the beginning of the period, that means that is an annuity due. So if it is annuity due, you have to add 1 plus I at the back of the formula. So that's the difference between calculating an ordinary annuity and annuity dues of a present value and future value. And that's the end of the topic 6, time value of money. I hope you get something from this lecture, and please do attempt to answer some questions in order for you to master, all right, this topic and be able to calculate whatever we have discussed just now. Thank you. Wish you all the best, and I'll see you guys in the next video. Thank you. Bye-bye.